Factors affecting electrode potential with explanation. Main emphasis on the temperature, concentration, and the nature of the electrode. This is the portion given in the syllabus. You must have a thorough idea about each point, then only you can do the assignments given at the end of this section. The electrode potential of an electrode assembly depends upon the following factors. 1. The nature of the metal and its ions. 2. The concentration of ions in the solution and the temperature. When an electrode assembly is in the standard state, that is, concentration of the ions is 1 moles per liter and the temperature is 298 Kelvin, and the pressure of the gas, if it is used, is 1 atmosphere, the value of the standard electrode potential can directly be obtained from the electrochemical series. That means a table is made with the reduction potentials of all the electrode assembly. Now, however, when an electrode assembly is not in the standard state, that is, the temperature is not 298 Kelvin, and its ion concentration is different from 1 moles per liter, and the pressure of the gas is different from 1 atmosphere, its electrode potential cannot be obtained directly from the electrochemical series, that is, from the table which is given. In such case, the electrode potential of the electrode assembly can be calculated with the help of an important equation called Nernst equation. This equation you have to get thorough with it so that only you can do the assignments given. The Nernst equation correlates the electrode potential to the temperature of the electrode and the concentration of the species involved. For an electrode involving the process of reduction, that is the reduction electrode, that is the one that normally and frequently used. The reason is that in the table the values are given, all are reduction potential. That means the reduction potential and the oxidation potential of an electrode assembly is always same but different sign. That is the important point. Nernst equation can be written as follows. That is, reduction potential of an electrode assembly is standard electrode potential, that is represented by E0 minus RT by NF log to the base C, concentration of the reduced state. This you should have a thorough idea. Concentration of the reduced state as a numerator and concentration of the oxidized state as a denominator. For an electrode involving the process of oxidation, an equation is given here, but this equation is not at all used. We follow this system because in the, as I told you earlier, in the electrochemical series, all the electrode assembly reduction potential is given. Then, if this is oxidation, there is a slight change here. That is E0 minus RT by NF log to the base C. Concentration of the oxidized state comes as a numerator and concentration of the reduced state comes as a denominator. You prefer to use the first equation because the electrochemical series, the values are all reduction potentials, where E is the reduction potential of the electrode assembly. E0 is equal to standard reduction potential of the same electrode assembly. R is equal to the gas constant 8.314 joules per Kelvin per mole. T is equal to the temperature of the electrode assembly. F is equal to 1 Faraday, that is 96,500 coulombs. N is equal to the number of moles of electrons gained by 1 mole of the oxidized state to get changed into the reduced state in the process of reduction occurring at the electrode. Electrons gained or lost. By the cell reaction, you have to find out the number of electrons gained or lost. If the electrons are differ in number, you have to multiply with a number and make it equal, and then you have to find out the number of electrons gained or lost. When for the examination you have question comes that write the Nernst equation and giving 1 mark, you have to specify all the representation, otherwise you are not going to get any marks. Now, what is the meaning of oxidized state? Concentration of the substance undergoing reduction. Now, reduced state, concentration of the substance obtained on reduction. These values you will understand by taking only an example. That means consider a case, that means Mn plus accepting 2 electron and get reduced to M. Consider this example. This equation can be written as the electrode assembly, that means the electrode potential of that reduction electrode is equal to E0 of that electrode potential electrode assembly minus RT by NF, concentration of the M, that is according to the equation, just see it is the reduced state. Reduced means it gained electron and get converted into M. Now divided by Mn plus, that is the one that is oxidized, that is my lost 2 electron and get converted into Mn plus. Now in the above equation, Mn plus aqueous is oxidized state because it is undergoing reduction. That means once it gets oxidized, only it gains electron and get converted into M. And because it is obtained on reduction, since the concentration of a solid is taken equal to unity, please remember to apply this rule when you do the assignments. That is, concentration of a metal or any solid form is equal to 1. Therefore, the equation can be written as electrode potential of the reduction electrode is equal to standard reduction potential of that electrode assembly minus 2.303, because we are going to change log to the base 10, divided by NF RT log to the base 10 1 by Mn aqueous. 1 means the concentration of the solid forms are always equal to 1. That is equation number 3. Equation 3 represents the relationship of the electrode potential, that is the reduction potential, with the temperature and the metal ion concentration, and may be used for the calculation of the electrode potential of an electrode assembly at different temperature and different metal ion concentration. Equation 3 can be changed into much simpler form if T is taken to be equal to 298 Kelvin, because all the experiments are normally conducted at room temperature. Therefore, we consider that T is equal to 298 Kelvin. And since most of the electrodes are set up and used at room temperature, a simpler equation may be obtained as follows for the cases studied at room temperature. That means we are going to substitute the value of T, and all other values which are constant also we put it and find out a value. For example, R is equal to 8.314 joules per Kelvin, T is equal to 298, F is equal to 96,500 coulomb, and in that case only unknown value is N, because depending upon the cell reaction this N will vary. Sometimes it may be equal and get 2. Therefore, you have to substitute depending upon the cell reaction. Therefore, the electrode potential of the reduction electrode is equal to standard reduction potential of that electrode assembly minus 0.059. You just calculate and find out whether you are getting this value if you substitute the temperature, if you substitute R, and if you substitute F. Then log to the base 10, concentration is 1 because it is in the solid state, and Mn, that is concentration, that is aqueous. Now it is aqueous. Sometimes the concentration will be given In that case, you can substitute instead of aqueous that concentration, for example 0.1 molar or 0.1 molar, like that the concentration will be given. Therefore, you get a final equation 4. This is the simplified form of Nernst equation and give the dependence of the reduction potential on concentration of the metal ion at 298 Kelvin. But the temperature is different. Don't substitute this at 298 here. If it is 298 only, you will get this value. Now, two assignments are given here based on the knowledge that we discussed now. The answers are given in the textbook. Don't refer the answers or the way of doing the assignment before doing it. You do the assignment based on the knowledge that you received. After that, you refer the textbook.